Assalamualaikum warahmatullahi wabarakatuh. Hello everybody. My name is Anggun Trisakti. I'm from Semarang State University. In this video, I want to tell you about acid and base titration. The basic computation about this topic is 3.1. Determine the acid and base solution based on acid-base titration result. Before we study about it, we must know what is acid, what is base, and then what is the titration. Acid is a properties with pH less than 7, base more than 7. Arrhenius said that acid can dissociate in water to form hydrogen ion. And then a base is a substance can dissociate in water to form hydroxide ion. Titration is a method to determine the concentration of a solution. Purpose of acid-base titration is determine the solution with a concentration that has known concentration, so that it is exactly used number of solution analyzed, or want to know the level of concentration. Equivalent point at which an titrans mole are stoichiometrically equal to the mole of acid or base in the sample. The smallest amount of titran need to fully neutralize or react with the analyte. Titration standards or known solution, either an acid or base, that is added during titration, analyte and known solution whose concentration is being determined in the titration. Okay, now how to setting up an acid and base titration? The solution in the flask contains an unknown number of equivalent of base or acid. The burette is calibrated to show volume to the nearest 0.001 centimeters cubic. It is filled with a solution of strong acid or base of known concentration. Small increments are added from the burette until at the end point, one drop change the indicator color permanently. And then an indication of the approaching equivalent point is a appearance and disappearance after stirring of the color that the indicator as stand beyond neutralization. At the equivalent point, the total amount of acid or base is recorded from the burette readings. And then, material for a titration procedure is burette, what type, and whether it is used to see a color change in the solution. Pipette, and then pH indicator, Erlenmeyer, Titration. Titration is a standard solution of known concentration. A common example is aqueous sodium carbonate. And then analyte or titration, it is the solution of unknown concentration. Equivalent point indicator. Okay, before you begin the titration, you must choose a suitable pH indicator, preferable one that will experience a color change, known as the endpoint, close to the reaction equivalent point. This is the point at which equivalent amount of the reaction and product have reacted. Below are some common equivalent point indicators. If we use strong acid and strong base titration, we must use phenolphthalein indicator. And then weak acid and weak base titration, we must use bromo-thimal blue. And then strong acid weak base titration, we must use methyl orange indicator. Now, I want to tell you how to conducting the titration. First, measure out a precise amount of analyte in a clean beaker or flask. You must know exactly how much of your analyte you are using so that you can calculate your end concentration. Use a pipette to measure out the necessary amount of analyte into your beaker. And then the second step is drop a small amount of color indicator into the beaker. Many titrations require the adding of a color indicator prior to adding the titrant. The specific type of color indicator unit will depend on what titrants you are looking for. Likewise, the amount of color indicator unit will depend on the volume of your analyte. Generally, you will need between 3 until 5 drops of indicator for 100 ml of analyte. And the third step is add your second chemical, if necessary. While not all titration experiments require a second chemical, some do. The second chemical is sometimes referred to as a buffer. If your titration requires a buffer, use a pipette or measured drop to add it to the analyte after you add the color indicator. And then fourth step is agitate the beaker using a magnetic stir plate. If you have a magnetic stir plate available, place your beaker on it and drop the agitator into the beaker. Turn the plant on slowly until the agitator is stirring enough to mix the solution in the beaker without splashing it on the beaker walls. You will leave the stir plate on until your titration is complete. If you do not have a magnetic stir plate, you can agitate the beaker by hand by gently swirling it 4 until 5 times before place it under the burette. And then the sixth step is slowly open the stopcock so that the titrant drops out of the burette. The titrant should come out of the burette drop by drop. Allow the titrant to drop into the analyte until you notice a color change in the beaker solution. The color change may be slight, so proceed slowly and watch carefully. If you notice a color change, close the stopcock and allow the agitator to run for 30 seconds. If the color dissipates before the 30-second mark, open the stopcock slightly and continue to add the titrant by drop until you get the permanent change. If you are not using a magnetic stir plate, close the stopcock once you notice the first flash of color change. Agitate the beaker to see if the color dissipates. If it does, replace the beaker under the burette and continue the titration. If it does not, you have reached your end point. And then the sixth step is slowly open the stopcock so that the titrant drops out of the burette. The titrant should come out of the burette drop by drop. Allow the titrant to drop into the analyte until you notice a color change in the beaker solution. The color change may be slight, so proceed slowly and watch carefully. If you notice a color change, close the stopcock and allow the agitator to run for 30 seconds. If the color dissipates before the 30-second mark, open the stopcock slightly and continue to add the titrant by drop until you get the permanent change. If you are not using a magnetic stir plate, close the stopcock once you notice the first flash of color change. agitate the beaker to see if the color dissipates. If it does, replace the beaker under the burette and continue the titration. If it does not, you have reached your endpoint. Then, seventh step is record your final volume from your burette. Once you have reached the endpoint of your titration, close the stopcock and record the final volume of your titrant into the burette. Subtract your final volume from your starting volume to get total volume of titrant at. When reading the end volume of your burette, make sure your edges are the level of the titrant meniscus. Take your reading from meniscus. Now, after you conduct the titration, I want to tell you how to finish your analyze. First, dispose of the chemical used in a label waste container. Once you have completed your titration, empty out your beakers, your burette, and any other glass you use into appropriate containers. If you are unsure of where these are, ask your instructor or lab directly. And then, second step is clean your glassware by rinsing them with water. And then, third step is calculate the concentration of the titrant. Every type of titration will require a different calculation to determine the concentration of titrant in your analyte. Perform your titration calculation or check a titration curve for your specific titrant to quantify your result. Calculation of the concentration should be done the appropriate number of significant figures. Ask your instructor or lab directly. I think that's enough. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh. Bye.